Yeah.
Okay. Your sound alive ah. Yang lain semua letih je I dengar. Dinesh Kumar.
Hello, doctor. Yes,
Yeah, how are you?
I'm good, doctor. How are you, doctor?
I'm fine, thank you. Where are you at the moment?
At home, doctor. It's raining here.
At home, where?
Klang, Selangor.
Oh, Klang Selangor. You're in the red zone, right?
Yes, doctor. That's why I couldn't go outside.
So you cannot come to UTM lah at all.
Yes. Yes.
Okay. Who's your supervisor?
Dr. Lau.
Dr. Lau. Oh, I asked you before, right? Yeah, sorry, I forgot lah. A lot of things to think.
It's okay, doctor.
Okay, now 18. Okay, the numbers is going up. I give another 3 minutes. Anything you want to ask me before we start the class? Have you guys watched the video on water jet machining? Aja Sophia, have you watched the video or not? Aja Sophia?
Yes, saya.
Dah tengok dah video tu, labnya.
Tak dengar.
Hello? Tak dengar? Orang lain boleh dengar I cakap, macam mana you tak dengar? Sekarang dengar?
Dengar.
Okay. You dah tengok video tak dekat untuk water jet labnya?
Belum.
Kenapa tak tengok lagi? Hari ni kan kelas water jet. Kalau tengok senang sikit I explain. You dekat mana Aja?
Ada dekat Melaka.
Melaka kat mana?
Dekat rumah sewa. Dekat air keruh.
Lain kali kalau I tanya, tak payah cakap I dekat rumah sewa. Cakap dekat mana saja tempat tu.
Okay.
I tahulah dekat rumah. Air keruh lah, dekat je. Memang orang Melaka lah. Oh, you datang untuk PSM lah. Siapa supervisor you?
Dr. Fauzi.
Dr. Fauzi? Dr. Fauzi JTKP lah? JTKP lah?
JKP.
Dr. Fauzi. Oh, dia ex-UTM ke? Alumni?
Rasanya dah naik.
I see. Kita punya student dulu lah.
Betul.
Okay. So you all pun boleh jadi lecturer dekat UTM juga lah, if you want lah. Okay guys, now I'm sharing the slide for this week. Okay.
Writing's not that easy, but
Okay, you all can see the slide?
This sentence.
Yes, doctor. We can see the slide.
Okay. Right, okay. Can we start now? Okay, for today's class, we're gonna cover on water jet machining. Okay, previously we have looked at last week we looked at the ultrasonic machining. So for ultrasonic machining, what are the key components? Anyone can, we do some refreshment. Okay, anyone? We have electrode or sonotrode, right? Then in between the sonotrode and workpiece, we have what type of fluid? Anyone, please? On your microphone, you can You can answer me.
What conductive fluid apa tu yang
Ultrasonic machining we have.
Ultrasonic.
Yeah. Last week is ultrasonic.
Ah,
So in between, right, between the sonotrode and workpiece, we have what type of fluid?
beaker? Bukan. Kejap.
Apa dia?
Saya pun jam
Anyone?
kejap.
Jangan jam. Right, anyone boleh jawab? Okay lah, straight away I give you the answer. It's slurry, right? Slurry, S-L-U-R-R-Y. Slurry is a mix of abrasive material and water. Or sometimes we can use oil, right, to carry the abrasive material instead of water. So ultrasonic, the using frequency between up to 50,000 kilohertz, right, for the sonotrode to vibrate, so that you can supply the kinetic energy to the abrasive material. Okay, the cutting mechanism is by indentation, right? Okay. So for this week one, we talk about water jet machining. By definition, is also known as hydrodynamic machining. When we talk about hydrodynamic, it's a combination of hydro. Okay, hydro is actually using fluid or water. Dynamic is something that is moving. So hydrodynamic means that we use mechanism of the moving water to do machining process. Okay, the water jet acts as a saw, right? Similar to later on, let's say you want to, we discuss about laser cutting, electron beam cutting, right? It's all similar with water jet machining. Okay, but water jet machining, can we can we machine blind hole? No? Anyone can we try?
Blind hole means straight away
Yeah.
through.
Blind, yeah. Blind hole.
Boleh
blind
if
means-
sharp enough ones can go.
Okay, this is blind, This is blind. If through hole is like this.
I think through hole, blind hole tu tak boleh sebab kuat sangat
Yeah.
kot.
Blind hole cannot, This one cannot. Through hole, yes. Because if let's say you do blind hole, all the debris, okay, all the abrasive material will reflect back to the working area, which is very dangerous. So for water jet machining, you can produce only through hole at the moment. We call it through hole. At the moment lah, maybe later on, let's say somebody have studied to do blind machining, right? Then maybe possible. So if let's say you can perform blind machining, okay, you can really extend the scope for water jet machining. Okay, maybe at the moment we can produce certain projects, certain workpiece or certain design, 2D project. Later on, maybe we can produce like mold, right? Similar to die sinking. Okay, the pressure range from 50 kilo psi to 200 kilo psi. It's very high. Okay, imagine that the water pressure. Let's say you want to wash your car, right? The psi is up to 1800 only. 1800 psi. That one also you can feel the pressure of the water already. But for water jet machining is up to 50,000 psi. 50,000 psi, very high. Or it can goes up to 200,000 psi. No, 200. Yeah, 200,000 psi. So very high. You can cut anything by using 200,000 psi. Okay, the diagram here is showing on the parts for the main water jet machining process. First, they call it high pressure inlet. Okay, this is water coming from, and water will come into this pressure water inlet. Then number two, we call it jewel, made of ruby or diamond. This is must made from very hard material, because this high pressure water gonna pass through this hollow, okay, path, right, to the nozzle. So without hard material here, okay, this high pressure water can always break through the path here, the narrow path. Go from big to small, you're gonna increase pressure as well. Beside the other attenuator, the compressor, and so on and so forth. Then abrasive material you supply through the side. Okay, and then we have number 3 and number 4, we have mixing tube. This one we call it mixing tube, where you mix the abrasive material and water. Cutting water jet. Okay, this is cutting water jet. Alright, then this is your place. This is the gut only. Okay. Next, water jet abrasive. Okay, there are 2 types of water jet machining. First, we call it only water jet machining. The other one is abrasive water jet. Okay, both involve mechanical energy of water and abrasive phases. For example, water jet machining only involve water, mechanical energy of water. But for abrasive, it's a combination between mechanical energy of water and abrasive phase, to achieve material removal or machining. Okay, WJM, AWJM can be achieved during different approach. Okay, for water jet only, we have 2 types. We have pure and with stabilizer. Okay, this one I'm gonna explain later on for the following slide. Then abrasive water jet also, we have 2 type of abrasive water jet. We call it entrained and suspended. Entrained is combination of abrasive, water and air. Suspended, abrasive and water ni. Actually both are almost similar. Okay, water is pumped sufficiently high pressure, 200 to 400 megapascal, to produce how much pressure? You pump the water using this 200 to 400 MPa, megapascal, to produce how much pressure of water?
Yeah, 1000 bar.
1000 bar?
4000 bar. 2 to 4000.
Yeah. No, this one megapascal is converted to bar, is 200 is 2000 bar. So this one is the water, pumping water, the pressure of pump, the pump pressure. So the water is pumped up to how many psi? 50 to 200 k psi. Okay, this is the pressure of water. This is the pressure of pump. Right. So next is intensifier. Work a simple principal pressure application using hydraulic cylinder, different cross section. Means that from bigger diameter to smaller diameter to much smaller diameter. Okay, from high, okay, water, this pressure, let's say P. Okay, when you arrive here, the pressure increase by double, 2P. When at the narrow one, maybe 3P. Means that as the cross section of the cylinder is getting smaller, the pressure is getting higher. Okay, this is similar to mechanism of gun, right? Rifle. Like when you have a gun, you have the barrel, right? The barrel is actually getting narrower towards the end. Here the diameter is much bigger compared to here. That's why the bullet can accelerate during shooting process. It will accelerate. So similar concept is using here, right, for water jet. By having smaller and smaller diameter of the cylinder, okay, because this is a pump. We pump water through this cylinder, right? So the pressure can increase. Okay, when the water pressure is show suitable orifice 0.2 to 0.4 mm diameter. This one is the orifice. Orifice means that here 0.2 to 0.4 mm. Okay. Potential energy of water is converted to kinetic energy. Okay, from potential energy because of the compressed air. Okay, compressed water, sorry. Compressed water, it develop potential energy, right? So this energy is then converted to kinetic energy to do cutting. Okay, the velocity of water can goes up to 1000 millimeter per second. It's very very high. So by this having this 1000 meter per second, you can cut anything: tin sheet, foil, aluminium, leather, textile, food, so on and so forth. Okay, so far any question? Guys, can you follow?
Okay, tapi
Yeah.
yang abrasive tu,
Abrasive what?
contoh kan ada macam untuk there are water jet for machining and there are used for like for cleaning also, right? Like high pressure cleaning, car wash and all
Okay.
that, right? So
Okay.
which one is actually, what's the difference? Is
The
it
difference?
is it abrasive slower or what?
Oh, is the pressure is actually low. Okay. Example this one Can you see this one? Car wash.
Yeah.
Water pressure to wash a car. So the PSI is only about 13 to 1800 PSI only.
Just different
Compared,
names not
sorry?
just different names for each type of water.
Because okay, not different name. Actually different pressure. Use different pressure for different purpose. For example, at this range of water pressure is for cleaning. This range of pressure, okay, 50,000 to 200,000 psi is for machining. Let's say there's another one for how we call it. I forgot the word. Let's say you want to remove paint, right? You want to wash, you remove all this paint, right, from the car body. You can add abrasive also, maybe walnuts, right, into the water pressure, so that you can add another force instead of just water.
Sandblasting.
You can also have sand, or you can also have a walnut, the skin. Sandblasting is slightly different. Sandblasting is only involves sand and air. Okay, pasir dan angin saja. That we talk about sandblasting But you can still have water sandblasting when you add water. Right, you can remove all this the paint from car body. So the range maybe this one instead of 1800, maybe this one goes to 5000 psi. So it depends on the pressure of water. It will determine what type of process, machining process. Okay, Raja.
Yeah.
Yeah. You got?
Yeah. Okay.
Faham Ada lagi yang lain? Anyone who want to ask? You can always ask me in Malay, no problem. Okay, if no question, then we proceed lah. Okay, next one, in pure water jet machining or WJM, right? Commercially, pure water use for machining process. Only water ni, tap water or pure water. Okay. However, when the high velocity water jet is discharged from the orifice, okay, when the water come out from the orifice or the nozzle, okay, the entrant atmospheric pressures tend to flare out because when the, okay, for example, this is nozzle. When the water come out from the nozzle, because of air, okay, in between your workpiece and the nozzle, because of existing of air, there's some resistance, okay, from the water to the workpiece. So if flare outs means that they tend to kembang lah, untuk pecah, like your spray, right? So in order to solve this problem, people normally add stabilizer. Stabilizer is a fluid contain polymer material, right? It can, this so-called long chain polymer, it will hold the water to be straight, okay, not flare out. So when it is straight, they can remain, you can maintain the pressure of water, right? So it's involved only water, but let's say you need to maintain the water pressure, you can add stabilizer. Okay, the stabilizer is made of long chain polymer. Okay, this is water jet. For abrasive water jet, we add abrasive particle, for example sand or silicon oxide. We can add glass bead, okay, garnite, silicon boron, silicon carbide, okay, aluminum oxide, any type of abrasive particle you can add into the water so that it can have additional cutting force instead of just water. Okay, mechanical energy of water, it can also have abrasive cutting force. Okay, there are two types of abrasive water jet. First we call it entrain, the other one is suspended types. So entrain means that you add the abrasive particle and the water together before it shoot out from the nozzle. So it can, the pressure, the speed of water can goes up to 800 meter per second. Next, we call it suspension water jet. There are two types. First, we call it indirect pumping. Another one is bypass principle. Indirect pumping means that you add water first, okay, then only add the abrasive material. Or we can have bypass principle, right? Bypass principle is more popular compared to the indirect pumping. Here you add abrasive material, you bypass water first, okay, at his channel mixing, abrasive mixing tube, okay, we add the abrasive material and water together before goes to the nozzle. These two I think is not important lah, is almost similar, the concept, the mechanism is slightly different, but the output, the outcome is very similar, it's the same. Okay, now process flow of the, how to produce the high pressure of water. Okay, I think later on we can look at the slide lah. Actually the slide is got some animation where how the water is actually from the hydraulic pump, right, to, we call it anticipier. This anticipier actually move, okay, horizontally, right, to produce high pressure. This is the, you see, from bigger diameter of cylinder to smaller diameter of cylinder. So by pushing the water, okay, side to side, actually create very high pressure. So the water can goes from the left or to the right. Right, goes to the, we call it attenuator. This is where you mix the abrasive material, right, and so on and so forth. Okay, these are the, you can read on your own, right? What is intensifier, bulk abrasive hopper. Hopper is actually where you put all the abrasive material before you supply to the machine. Right. Similar to when we talk about injection molding, also we have hopper. Hopper is actually to store all the material. So in this case, we will store the abrasive material. Right. For the injection molding, we store pellet, plastic pellet. Okay, next, I think this one no need to. Okay, you can read on your own what is attenuator, abrasive metering material. This is metering material, right? Because it's transparent, you can look at the how much abrasive material that we have during the cutting process. If insufficient, you can add into the hopper. Okay, process capability, you can use to cut any material up to 1 foot. Okay, 12 inch. Very thick material. Okay, can cut, start at any location without pre-drill hole. Okay, let's say you have this plate, right? You want to cut from, you can to cut a hole, right? If you use EDM wire cut, you cannot straight away put your wire through this hole. You have to make a hole first, then you can insert your wire, then you do cutting. But water jet machining, you don't have to put, you don't have to drill any hole at any location. You can machine at any place that you want, any location. It's similar to laser jet lah. You can put your the nozzle here, start the machining process, straight away cutting. No need the pre-drill hole. No heat produced because of the water. Water is actually automatically cooling the working area. And no flexible machine cut, therefore suitable for flexible material. It says here, no flex to the material being cut because of very high pressure, right? It will not flex the material because there's no contact, right, between the nozzle and the workpiece, so it will not flex the material. Okay, let's say you have this thin flexible material you want to cut, right? Because the nozzle, right, is not touching the material, so it will not flex. Let's say the nozzle, or you use any type of conventional machining, you will touch the cutting tool will touch the workpiece, so it will tend to bend the workpiece. So water jet is also suitable for flexible material. Okay, little wetting of the workpiece. Okay, no burr produced. Okay, environmental safely. Burr means that at the cutting end, there's no burr here. I think actually there's burr, but it's very minimum. Okay, next it goes to the application. Okay, for water jet only, you can cut food product, paper industry, fiberglass, okay, automotive. You can cut carpet, door panels, and so on and so forth. Okay, this one, let's say you want to put abrasive, also no problem. You can also use abrasive water jet. But for food product, we don't allow abrasive. No abrasive because it will contaminate the food. Okay, for water jet machining, you can cut harder material for hard application. You can cut metal, steel, titanium, ceramic, composite, glass, concrete, and so on and so forth. Rubber, okay, rubber actually you can cut by only water jet, no need abrasive water jet. Okay, but this one you cannot use water jet only because it's not strong enough to cut all this material. Right, then talk about abrasive. Okay, depend on the mesh number. Okay, the mesh number from 36 to 150. When we talk about mesh again, I remind you, the smaller the number, the bigger will be the abrasive size. Okay, 36 means that the number of grit is 36 per inch, per square inch. So the grit size abrasive is bigger compared to 150, means that per square inch there will be 150 holes. Okay, like tapis lah. So the abrasive is smaller, the size. 80 is quite common. 80 mesh. Okay, all this sand normally can be found in Africa, Brazil, Canada, India, Sri Lanka, Madagascar, and USA. Okay, so far we cannot find this sand in Malaysia lah. We cannot use the sand in Terengganu beach even though the thing is very small, very fine, right? That is not fine enough. Okay, process parameter. These are all the process parameter you can control to actually optimize the water jet machining process. And MR, okay, material removal rate is proportionally okay, directly involved with the pressure, water pressure. Okay, or even to calculate MR equal to HT, W, and V. What is HT? Is depth of penetration, width of curve, right? Then V is transverse speed. Transverse speed means that, okay, let's say you want to cut this square. Transverse speed means that how fast the nozzle is moving. Okay, the speed of nozzle. Okay, depth of penetration means that the thickness of the workpiece. Okay, this one HT. Width of curve, okay, top and bottom means that this is curve. This is curve. Curve means that the hole, that the path or the gap between the cutting the workpiece lah. Okay, this is top and this is bottom. Okay, this is top diameter D1, or this one bottom one we call it T2. So to get the average, D2, D1 plus D2 divided by 2. Okay, very simple lah, the MR calculation. Okay, this one talk about this one I already explained just now. Okay, this one is burr, right? This one is curve bottom, this one curve top curve. Okay, this is actually the actual cross section. Then we have, we call it striation. This one striation comes from the cutting process, from the abrasive material, abrasive effect. Right, similar when you do machining by CNC, you do cutting too. There will always be a striation mark. Okay, as you can see, the striation mark is actually is a shape of like this, is a up shape, because the pressure from top to bottom is actually dropping. At the top, the pressure is maximum. So when it goes to the bottom one, is actually dropping to minimum pressure because of the resistance of the material, right? But even though the pressure is dropping, the leftover pressure is still very high. That's why we use water, actually water tank, right, to actually catch or to reduce the pressure of the water. I think you have to watch the video to actually understand more on the process. Okay, cost. Okay, as an engineer, cost calculation is very important. You have to know the cost of your process. Okay, for example, for water jet machining, the estimated cost is about, this one talk about dollars, $17 to $20 per hour, which is include the utilities, right? Normally electricity, water, or rental if you have, right? Then maintenance cost, the seal, okay, booster, pump filter, and other miscellaneous lah. This one also, these are all the criteria you have to factor in when you calculate the cost. Consumable, right? We talk about orifice, focusing tube, garnet, and so on and so forth. And then this is how they calculate the cost. Okay, for machining cost. For example, orifice, the price is $14 to $20, right? It can last for 40 hours. So per hour, it's about 50 cents per hour. For nozzle example, one nozzle costs you about $85. Okay, it can last about 80 hours. Okay, so 1 hour costs you about $1. So based on this, all the fractional cost, right, you have to factor into the actual cost when you do machining, right? Then you have to insert operator how much per hour, maybe $20 per hour. Okay, capital monthly payment, let's say you loan the machine, so you have to pay how much, maybe 10,000 per month, right? So you have to calculate per month. This one you have to convert into hours, right? So normally when a customer comes to you as an engineer, he will ask you to give the quotation, right? So based on this calculation, you can give straight away the quotation to your customer. But normally you have to mark up a bit because this one is not include the machine efficiency. Example, if your machine efficiency is about 80%, you have to times 1.2 from this. Or you want to play safe, maybe you can times 1.5, or you have to times 2 times of the actual cost to get a profit. Okay, later on also we can cover ROI. Okay, what is ROI, return of investment, break even, and so on and so forth. So as engineer, all these term you have to be familiarize. Okay, so far any question? Hello?
Okay. But you have to change
I
the
check.
nozzle, or is it every time?
Change nozzle, okay.
Not nozzle lah, I mean like every parts also have to change because they don't last long, is it? 40
Yes, yes.
hours, 40 hours is like what, 2 days?
Okay, when we talk about 40 hours, don't misinterpret. 40 hours means that 40 hours of machining process.
Yeah, I understand that. But then
Machining process means that if you run the machine without stopping for 40 hours, then you have to change.
this thing all
Orifice nozzle.
this thing all
Let's,
cepat haus lah.
of course, this one last 40 hours normally were given by the supplier lah. Let's say you last 40 hours, the price will be equivalent to 40 hours punya harga lah, because you say this one $14 to $20, right? So it's quite cheap. But all this price, all this cost, you can claim to the customer later on. You will include into the customer quotation. So 40 hours is not talk about this, it's talk about machining time. Let's say one day, right? You do water jet only for 2 hours only per day. So 40 hours you can last about how many days? 20 days, right? So like all these so-called regular parts you have to be replaced. As an engineer, you have to keep stock lah. Nozzle, right? You can last 80 hours. For example, orifice, you have to keep stock so that it will not stop the machining process. Okay, good question. Ada lagi soalan? Any more question? Any question? I think you have to ask me a lot of questions about water jet machining, because next week you have to do the report already on water jet. Tak ada soalan ke? Okay, okay, good. Okay, next. Let's see. Wah, ada 33 orang je. Ramai tak datang. What happened? At the moment only 33 people ni. Siapa yang tak ada ni kawan-kawan tolong Roger dia orang. Hamdan, Amirul, Aizat semua tak ada ni. Okay, next we goes to next slide. Wait, where's the next slide? Boleh nampak slide ni? Hello?
Slide yang sama je, yang cost.
Okay, good. I nak ni nampak ke tak nampak lah. So the one previous. Okay, next one talk about advantages of the water jet machining. Right, good surface finish, no temperature change, very little scrap, negligible cutting force. Right, these are all the advantages of water jet machining. Easy automation, no pollution, and so on and so forth lah. Okay, disadvantage, right? The hourly rate is high. Okay, but this is also relative to the type of project that you do lah. If your project is a high-end project, right, maybe it's worth it to do water jet machining. Otherwise, you can use all the non-conventional machining process lah. It's cheaper because hourly rate high, contribute by all the cost just now we mentioned, and also the capital cost, the first investment of the machine. Right, the machine maybe cost about 500,000 per machine, depending on the spec that you want to have. Other disadvantage, not suitable for mass production. Right, please remember, it's not for mass production. That's why the orifice can last only 40 hours only. So normally we have small project, but then only you cut by using water jet machining. If you use for mass production, maybe like what Raja said, maybe every 2 days we have to change the orifice. This orifice changing, we call it setup cost. This one also you have to factor in when you calculate the cost. Alright. Short nozzle lifetime. Okay, short nozzle lifetime. Nozzle about 80 hours only. Right. Hazard from rebounding abrasive. Let's say the material is very hard, right? Normally when initial cutting, all the abrasive will bounce back, okay, until you can pass through the material. Then only you can cut the side only. But normally during initial one, all the abrasive material will bounce back. So you cannot sit near to the machine area. You have to stay very far, or you have to put some guard to protect yourself. Okay, technology comparison. Actually, you haven't covered laser yet, but you can compare EDM and water jet. Right? In terms of advantages, right? Material thickness, cut off material, no HAZ. Okay, these are the most important advantage compared to EDM. No distortion, edge quality, right? Okay, equipment cost. Actually, EDM is expensive. Okay, the cost is higher compared to water jet lah. Disadvantage for EDM. These are the disadvantage. Okay, disadvantage: pump maintenance, slower cutting rate, equipment cost, and so on and so forth lah. Okay, laser later on we're gonna take a look. Environmental issue. Actually, there's not much environmental issue for water jet machining, except for water recycling. You have to recycle the water. Actually, this one, all the machine is doing the recycling. Okay, spent water disposal, chip recovery, abrasive recovery. All this abrasive material you can recover, you can use back, you can collect from the catch tank. When you talk about catch tank, it's actually the tank. You put your workpiece here, right? This is your water jet cutting, right? All the abrasive material is actually will fall into the, we call it catch tank. Catch tank, tangki menangkap. This one all water. So it will catch all the abrasive material and deposited at the bottom of the tank. So later on, maybe you can dry off the tank and reclaim all this abrasive material, re-dry and reuse. Okay, safety issue first is noise, right? But the noise is up to 72 decibel. Okay, for human one, for safety like OSHA one, is actually less than 85 decibel. It's permitted lah, less than permitted lah. Okay, for operator safety is less than 85 decibel. Above 85 is not safe for human to operate the machine. So we have to do something. But for water jet is quite high, but it's still below the permission decibel. Tube rupture, right? Because of high pressure, potential of tube rupture is quite high. So you have to stay not close to the working area, or you can wear all the PPE like your goggle and so on and so forth lah. Cash tank, absorb energy. Okay, maybe machine enclosed, open at top. This one, or maybe you can put some guard or whatever. Then water jet, comparison between laser and water jet. Like laser cut, you can see all this dark area is actually caused by HAZ, caused by heating. It's burn mark. Okay, here also you can see water jet is very clean. Okay, for laser cut is quite dark. This one is burn mark and have HAZ problem. Okay, some of the sample. Okay, for example, this one you cut meat, chicken. You can cut using water jet. You can cut all these panels, right, from aluminium, ceramic, or this block. Okay, MyStay block. Okay, you can cut gears. Okay, again this one is stone, right, or aluminium sheet. Okay, this was not. It's actually some 3D application, but it's the latest technology lah, because you can actually tilted the nozzle angle instead of just straight cutting. You can tilt, right, so that you can cut some so-called 3D workpiece. Okay, ada soalan? Any question? Okay, are you sure? Are you sure you are okay?
Yang okay lagi.
Okay, I ambil attendance sekarang because only 35. I don't want to wait anymore because I'm afraid the 35 pun akan kurang. Okay, so now we go to quiz. Please, I ask your name, please answer. Okay, first question. Boleh nampak soalan tak? Boleh nampak? Nampak Belinda Puratika. Belinda Oh, Belinda tak ada. Nurai Datul Sufiantin.
Ya, doktor.
Ya, you first time I call nama you. Bukan nama you pelik ni, Nurai Datul. Alright, first question. Water jet machining cannot be used to machine apa? Tak boleh machine apa? A, B, C, D. Frozen food, plywood, leather, steel plate.
Plywood.
Kenapa? Why plywood? Why?
Steel plates.
Nurai Datul?
Ya, doktor, sekejap.
Sekejap, tak payah sekejap. Actually, among these three, let's say you tak ada jawapan D, steel plate, Nurai Datul, you listen to me.
sebab high velocity water jet can
Okay,
mention
wait, you dengar I cakap Okay, listen Let's say you tak ada steel, right? Tak ada steel plate D maybe you can answer B, plywood. Because among these three, plywood is the harder material compared to leather and frozen food. Am I right? Nuraidatul, boleh betul tak? Nuraidatul?
Ya.
Hello?
Suara doktor terputus-putus.
Putus-putus. You mana ni? Sabah
Sabah.
You dekat Sabah sekarang
Di rumah.
Di rumah. Okay, sekarang jawapan dia D
Steel plates.
Steel plate. Okay. Because steel plate dekat dalam among all these three, the four answers, steel plate is actually the hardest. So water jet machining tak ada abrasive. So steel plate memang tak boleh potong lah because it's very hard material. Okay, next question number 2. Venue. Vikanesh.
Yes, doctor. Yes.
Yeah. Number 2. Abrasive water jet mixing process take place in intensifier. No. Intensifier is actually to do what? What is intensifier?
Yes, doctor. Answer A.
Mixing chamber.
Mixing chamber. Okay, correct. Ada orang nak tolong you. Intensifier ni. Ni intensifier. Actually to increase the pressure of water. Okay. Yes, next question. Nur Alia. Ada Nur Alia tak? Nur Alia binti Muhammad Zaki.
Abrasive water jet velocity increase with keeping all others.
Tak ada Melanie Lai Chok Zin. Melanie. Hello. Ada siapa nak jawab tak soalan number 3? Saya panggil semua tak ada ni.
Increasing mass flow rate.
Increasing mass flow rate. Okay. Abrasive. Siapa ni?
Alia, saya.
Okay, Alia ada Okay, abrasive water jet.
Tak Alia Ibrahim.
Oh, ni Alia lain Okay, sorry. Abrasive water jet velocity increase with keeping with other parameter unchanged. You jawab tadi apa? Increase
mass flow rate.
mass flow rate. Abrasive material increase with. Okay, macam mana you nak increasekan velocity?
Increase mass velocity by tinggikan pressure.
Okay, kalau you jawab D, increase mass flow rate of abrasive. Lagi banyak you masukkan abrasive dekat dalam air tu akan jadi apa?
Air itu akan jadi makin laju makin kuat.
Dia akan jadi berat. Tahu tak? Dia akan jadi berat. So air tu nak bergerak akan jadi perlahan.
Okay.
Because dia nak kena carry all the abrasive material, right? So actually kalau you nak increase velocity of water jet, you have to decrease the flow rate of abrasive. Decrease. You can kurangkan abrasive then baru boleh you increase dia punya velocity.
Macam tu.
Yeah.
Okay.
Let's say you increase dia punya abrasive dalam tu, dia akan jadi lebih perlahan lah.
Bukan increase
Bukan increase, dia decrease.
Okay.
Right?
Alright.
Okay, soalan nombor 4. Radin ada tak? Radin, number 4. In an environmental friendly development concerning abrasive water jet, the following is used as abrasive material. Apa? Dry ice. jadi abrasive material. Tahu tak apa dry ice?
Bantai.
You nak jadikan dia abrasive material.
Crystal.
Kristal, dry ice tu macam kristal lah. Dia tu yang apa? You nak sejukkan you punya makanan kan? Dia ais yang dry ice lah. Alright. Okay, jawapannya apa? It's not dry ice Actually you boleh guna
Tungsten carbide.
tungsten carbide. Actually you boleh guna cubic boron nitride.
Boron nitride.
Yeah. Cubic boron nitride ni actually macam sand juga. Okay. Next. Dah habis dah? Finish lah. Okay, so any question? Ada apa-apa yang tak faham? You want me to clarify? Please. Okay, kita punya slide dah habis lah.
Tak ada dah. Okay, je.
So anything you want to ask me?
Bila cuti midterm?
Bila apa?
Cuti midterm bila?
Cuti midterm?
Next week lah.
Cuti midterm next week lah? Cuti midterm you tanya I. Oh, tu tanya pasal water jet, you tanya cuti midterm. Next
Tapi
week
bukan
lah?
next week dia kata ada ni ya.
Bukanlah, sepatutnya cuti
Sebab tu
midterm
dah
lah.
confused. Dia ada
Dia
kata exam lah.
You confuse, I lagi confuse lah. I langsung tak ambil pot lah you punya cuti ni. Lain-lain, next question, I tak tahu jawapannya.
Betul.
I'm sorry. Nazmeh, ni Siti Alia ada nak tanya ke?
Tak ada data.
Okay, you tengok I punya video nanti, ada satu I purposely mark mistake Nanti you all boleh try to point out lah apa mistake. Actually dalam apa tu? Soalan nanti dalam you punya lab sheet ada beberapa soalan yang you kena fikir tau. Alright, because I tak cover pun dekat dalam MS slide ni. For example, apa problem yang normally you face during water jet machining. Okay, so kalau tak ada soalan nanti you boleh Google lah. Nazir Ali,
Ya saya doktor.
ada soalan?
Buat masa ni tak ada.
Buat masa ni tak ada, Alhamdulillah. So I expect you all dapat A lah semua faham.
InsyaAllah doktor.
Baiklah. Tak senang soalan susah You expect, because C5 I mean soalan all about if you are an engineer. You have to imagine you put your feet in the engineer shoes. You bayangkan you engineer dekat factory. Itulah kebanyakan soalannya akan berkisar pada if you are an engineer.
Senario ke?
Sorry?
Senario ke?
It's
Case
not a
study-
scenario.
case
It's
study
it's just a case study lah. Okay, so kalau tak ada apa-apa, next Thursday I gonna see group 1 for tutorial 10 o'clock. Alright, so let's stop here. Now wait, I want to take one more attendance because now it's 37. Okay, so kalau tak ada apa-apa, thank you very much. See you next week.